Third, it's time to introduce our first speaker, Eli. So Eli is a mobile engineer working on GitHub for iOS. Sorry for that mishap. Eli has been working with iOS since 2010 and has a passion for pixel perfection and loves to teach computers to solve problems so that humans don't have to. When he's not writing Swift, GraphQL, or Ruby, you will probably find Eli brewing coffee and hanging out with his chatty Siamese cat. Without any further delay, I bring you Eli.
Hey, how's it going, y'all?
The going
Awesome.
is good. How are you?
Doing well, doing well. Happy to give this talk. I'm super excited to chat a little bit more about how we've been using GraphQL introspection at GitHub to build some really great tools
Mhm.
and to ship really great, awesome products to our developers.
Awesome. I'm looking forward to the talk. Are you
Cool.
ready to present?
I believe so. Let me share my screen real quick and we'll get started.
Cool. Adding it to the stream. Awesome. Take it away.
Awesome. Let's do it. Well, thanks for joining me, y'all. This talk's called Unlocking Static Type Superpowers with GraphQL Introspection. I'm Eli Perkins. Like Alex mentioned, I work on GitHub for iOS. I'm on the mobile team here at GitHub, been here about a little over 2 years now. And I'm excited to talk a little bit more about some of the fun things that we've been working on. GraphQL has really enabled folks to build some fantastic products by allowing developers to query for just the properties that they need when they need them. We often learn how to work with a given GraphQL server by using tools like Graphical to explore the schema, or downloading the schema directly to use locally with other tools like Apollo's CodeGen or GraphQL Code Generator. But what is it that we're really downloading? How is it that Graphical or Apollo Explorer or other tools know exactly what fields are available on each type? When we download a GraphQL schema, how did this server put together that schema for us? What is it that it actually did there? And how do the types from a GraphQL schema get turned into types in, say, TypeScript or in Swift or in Kotlin or in Java or other type-safe languages? And if other folks have built cool things like these in the past, what cool things can I build with a little bit more knowledge about GraphQL schemas, about GraphQL types, and more? At GitHub, we really enjoy digging into the nitty-gritty of GraphQL. We use GraphQL to power how developers across the globe connect, whether that's on github.com or on GitHub Mobile, or through third-party developers like you who use our GraphQL API to build new technologies and communities. Today, I want to dig into a really interesting topic, taking a look at GraphQL introspection and how the type system defined within GraphQL can be leveraged to solve problems in a unique way. We'll dig briefly into how GitHub CLI uses introspection at runtime to serve not only our customers on github.com, but our GitHub Enterprise users as well. And lastly, we'll take a peek at how using introspection and GraphQL schemas as an input to other tooling helps our mobile team ship new features to many customers automatically. So let's dig in. What is GraphQL introspection? GraphQL introspection is how we ask a given server about its schema, and how we ask that schema about its types, its queries, its mutations, subscriptions, directives, and more. Introspection quite literally means examining or observing within. So with GraphQL, introspecting is no different. We look within to see what's inside of a given server, what's inside of a given schema, or what's inside of a given type. There are two main ways to do introspection with GraphQL, and both of them involve querying a GraphQL server directly. Schema is how we introspect GraphQL server from the root of the server. Think queries and mutations. While type is how we ask a GraphQL server about one specific object or one specific interface at a time. Note how these two fields are prefixed with two underscores, indicating their almost private nature. Let's start by taking a look at the schema field. The schema field gives us an entry point into our graph. Asking the GraphQL server for its query type will offer up the type that our whole schema can be queried against. This might seem obvious at first. We write a lot of our queries starting with the query field. Similar fields for mutations and subscriptions also exist, defining the core groups of ways that any given developer can interact with a GraphQL server. The schema field also allows for asking a GraphQL server for all of the types that it has to offer. This is the bread and butter of GraphQL after all, defining the types along the graph. This is what gives us our type safety as we're developing applications. Further information beyond just queries and mutations can also be fetched from via introspection as well. Perhaps your server defines some unique directives that can be used within your GraphQL queries. The directives field on the schema will let you know exactly what directives are available for you to use with a given server. Here's an example of hitting the GitHub GraphQL server to get the include or skip directives, knowing that we can execute these against the GitHub API server. That's just a brief overview of some of the properties that exist on the schema type. Now that we've grabbed a list of all of the types that our server supports, let's poke a little at one single type using the type field. Type allows for querying one specific type, given that you know the name of that type already. In this example, we can query against the repository type and see what is the description of that specific type. Types include fields as well. Now we're starting to see how the graph is actually built up. Here we've queried for all of the fields available on the repository type. It even let us know which fields will be non-nullable or nullable as well, beyond just the scalar type that backs that field. Types can also include descriptions. This is how GraphQL is able to self-document the types and the fields that it exposes by baking the documentation into the query language itself. So that's our 2-minute tour of the two of the entry points into GraphQL introspection. But there's one more introspection field that you might already be familiar with and might be using today. And that's type name. Type name exists on every object within the GraphQL schema. You might have used this in the past to determine what the concrete type is of an object that you've received, perhaps from a union or from an interface. Fun fact, since schemas are a type as well, we can query for the schema field that we started taking a look at with the type field as well. Supplying that underscore underscore schema for the type name here brings us right back to the type that we started looking at. I could dig more into each of these types going field by field, but I'm not here to read documentation to you. I want to show you some of the cool things that you can actually do with introspection. Now that we know a little bit more about how to ask a server for its types, let's come up with some questions to have about a GraphQL schema itself. Given that we can query for all types against a given schema that a server supports, let's ask the GitHub GraphQL API how many different types that it exposes. As of this talk, that number was right around 1,182. This is using the GitHub CLI to query against this. A great way to execute queries quickly from your command line. Or perhaps that you want to dump an entire GraphQL server's schema. You can build GraphQL 2.0 or perhaps an app to explore GraphQL schemas in VR. We could write a recursive query ourselves to ask every type for all of its fields, and all of those types fields, and all of those fields types, and all of those types fields, and so on and so on. But much of the GraphQL community has settled on this specific query for introspecting the entire GraphQL schema within the GraphQL JS reference implementation on graphql.org. The query itself isn't too complex, honestly, coming in at about 100 lines of code, give or take a few conditionals. Executing this query will give you all information about every type, every mutation, every query, every directive, everything about a GraphQL schema. Running it against GitHub's GraphQL API is no joke. This introspection query returns a lot of information, maybe too much for a human. But now that we've seen all of this, let's start putting this type system, these type definitions, this data to use, using computers. Here's one of my favorite classic examples of how we're using GraphQL introspection at GitHub to help our developers out. We add things to our GraphQL schema, tweak things, deprecate things, a bunch. Sometimes weekly, sometimes even more. One way that we help keep developers informed about these changes are through the changelog published on our docs page. This calls out new GraphQL fields that get added as soon as they're deployed. So how does this work? The process for this is publicly accessible within our docs repo and is essentially a two-step process. Every day, our docs repo kicks off a GitHub action workflow to run this process. It starts by downloading the current introspection from our GraphQL API and comparing it to the previous one that the workflow last ran against. It uses the diff of these two schemas, the previous one and the current one, to find additions, deprecations, to indicate feature previews or other upcoming changes. All of this is powered by dumping the GraphQL schema via GraphQL introspection. Since GraphQL schemas are data and types that we can work with, determining the difference between two schemas is no different than diffing two objects or two JSON structures. With a little bit of code, we can teach machines how to help us humans how to build better products with GraphQL. So far, we've looked at how you can query a GraphQL server for its whole schema, or how a developer might poke at a specific type. We might be familiar with downloading whole schemas to do some work on with them, but let's dig in a little bit more. Let's take a deeper look at some other ways that GraphQL introspection might be helpful as a more precise tool during the runtime of an app. GitHub CLI brings GitHub right to your terminal. A good chunk of GitHub CLI relies on GraphQL to fetch the data that you need about a given pull request or to submit a review for that pull request that you just reviewed from your terminal. At GitHub, we love GraphQL, and the CLI gives me my favorite way to access our GraphQL API with ease. It's one of my favorite ways to quickly query our GraphQL API, handling authentication for me, or even giving me a convenient way to connect GraphQL API requests or other data within command line tools that I use on my day-to-day. One feature of the CLI that's quite neat is the ability to see the status of all pull requests on a repo. This includes things like showing the status check state, whether my CI checks are failing, as well as indicating PRs that are open, as seen in green here, or in draft, as seen in gray here as well. A GraphQL query to fetch this information is pretty straightforward. We can ask the graph for some properties, pulling out the draft status, as well as PR status checks from the commit. These features were able to be added to our CLI quickly and efficiently, thanks to GraphQL and GitHub's GraphQL API. By adding the isDraft field to our query, I've got just the data I need to get going. However, if I ask our GraphQL API for some field that doesn't exist, things start to get ugly. Perhaps I want to see if dark mode is enabled for a given PR. If this field doesn't exist on my type in my schema, my query is not going to be happy. Errors like this lead to no data coming back, as the query cannot even be processed by our servers, meaning our resolvers don't even get a chance to run. This can lead to really tough issues for our users. If we as developers write invalid GraphQL queries, our users will end up with blank screens, errors, or even crashes at runtime. Issues like this aren't so uncommon for us here at GitHub, but we've looked on how to try to fix these. When we develop new features, it's often easiest for hubbers to develop against github.com, or what we lovingly call the monolith or .com. Using code spaces, any developer can get their own mini github.com up and running to develop against, emulating a similar environment as to what will end up in production. However, GitHub Enterprise is one of the best ways to bring experienced developers that developers know and love to enterprise scale companies who need more security, like VPN access or on-site databases. Just because a new feature we've built works against github.com doesn't mean that it will work against GitHub Enterprise right out of the box. This product has a different release cycle, and some enterprise organizations might not upgrade their own servers very often. As such, we need to build our apps that talk to GitHub GraphQL APIs with a long tail of releases in mind, supporting all of our customers, not just those on github.com. So how can we leverage GraphQL introspection to do that? One awesome way that our CLI team came up with is dynamic queries. By executing a GraphQL introspection request for only specific types, our CLI is able to determine if a given server supports a specific feature or not. It can dynamically change the query that's executed in order not to throw errors at runtime. By removing fields that are unsupported by a given GraphQL server, we can avoid executing queries that we know will fail at runtime. This also has the upside of supporting future versions of GitHub Enterprise as well, which might support these fields in the future. Within the CLI, a request for the fields of a specific type are requested using the type field on our schema. In this case, we've asked the commit and the pull request types a little bit more about the fields that they support. We can check to see if isDraft is in here or if the status check rollup field exists as well. Since this returns all fields that these types support, we can look for specific ones that we're about to query for in the list of fields that are returned. On github.com, these fields should always exist, so we can query for them no problem. And on GitHub Enterprise, we can omit these fields from our query, allowing this query to be executed against these servers without throwing errors for undefined fields. Where before these fields might cause errors, using dynamic queries and introspection, we can omit them if the server does not support them and allow our queries to succeed without error. There are several different commands within the GitHub CLI that use this approach today, using introspection as feature detection, enabling the CLI to gracefully degrade its feature set when a given GraphQL server might not support that feature. It's a really great concept, and I encourage you to go take a look at it. So we've talked a little bit about how a schema from introspection can be used directly, and about how introspection can be used at runtime as feature detection. But I want to talk about one more thing that we've actively been working on within the mobile team. GitHub Mobile is the perfect use case for GraphQL. By requesting just the information needed by the app, we can save our users bandwidth and cell phone batteries with GraphQL, executing slim, efficient queries. Our mobile team loves GraphQL too. Here's a quick overview of all of the queries, mutations, fragments in the iOS app. The lines between fragments are shared between queries. You can see there's a lot of fragments shared within our code base, mainly due to core components like user list items or repo list items appearing in many places within the app. That's a lot of GraphQL here. And similarly to the CLI, our code base supports GitHub Enterprise Server as well. Our original implementation of this within the mobile apps was to support GitHub Enterprise Server a bit naively. We duplicated queries as needed for GitHub Enterprise. However, at times this meant duplicating entire trees of queries and fragments, which created a lot of code, maybe too much code. Our mobile team has been using Apollo on both iOS and Android to help turn our GraphQL queries, fragments, and mutations into executable Swift and Kotlin code. The type safety that Apollo gives our code bases has allowed us to build features rapidly and safely, but it hasn't been without its downsides. Let's take a look at one specific example. Using Apollo for iOS within the code base looks something like this. A developer writes a query for their feature using plain old GraphQL syntax in a .graphql file. Apollo's CodeGen tool uses the GraphQL schema to turn that query document into Swift types, allowing that query to be executed and parsed with type safety. Our developers then use the code generated by Apollo to build their features. Pretty straightforward. However, if we end up targeting multiple GraphQL schemas and have multiple GraphQL documents for each schema, then we end up with not only multiple GraphQL files too, but also multiple Swift types, which then themselves can sometimes be duplicated. This leads to developers hacking together some sort of semblance of versioning by appending version names to the query. It's not great. It worked fine for us to get the initial support of GitHub Enterprise out to our customers and unblock them from using the mobile app, but I think we can do better. Just like our CLI counterparts, we had to consider how to gracefully degrade the app when a given GitHub Enterprise server didn't support fields that we might be querying for on github.com. However, unlike our CLI counterparts, given the number of queries that our app makes and how our code base utilizes fragments to co-locate data requirements for their views, doing introspection checks at runtime from our users' mobile devices on mobile networks didn't seem like a scalable solution. We'd be spending a lot of battery and a lot of our customers' data on their mobile devices to do these runtime checks. We reached for a tool to help us, one that we had already been using internally for GitHub for some time, and that's GraphQL Ruby. GraphQL Ruby is a Ruby gem with a fantastic set of bindings around GraphQL ASTs, resolvers, GraphQL primitives, and other GraphQL utilities. GraphQL Ruby is what we use to power the GitHub GraphQL API. Ever fired off a GraphQL request to a GitHub GraphQL API? Yep, that response was powered by GraphQL Ruby. And our approach looks something like this to use GraphQL Ruby. We wanted developers to be able to write one GraphQL query for all schemas. We took a look at the different ways that GraphQL changes might affect our app and came up with an approach to use GraphQL introspection, allowing users to write one query for all schemas. From here, we would code gen separate GraphQL queries for each schema. This meant that one GraphQL query could turn into n number of GraphQL queries. In our case, one query for github.com, one query for GitHub Enterprise 3.0, one query for GitHub Enterprise 3.1. From here, we would then code gen one specific interface for any schema that our app supports, making building features for github.com and GitHub Enterprise quick and easy. This meant that product engineers only had to consume one interface rather than n number of interfaces or 3 different interfaces. Let's take a look. Let's try to visualize this pipeline a little bit and see how this might look. So starting with our GraphQL documents and all of the different schemas that we support, we built a tool with GraphQL Ruby to build what we call our GraphQL pipeline. Starting with a single set of GraphQL documents and multiple schema definitions, we can use GraphQL Ruby to begin to rewrite queries for each different server that we support. Using the results of GraphQL introspection and a little bit of ahead of time GraphQL AST parsing, we can decide which fields are supported by each schema before the code is ever run on our users' devices. However, this approach still leaves us in a similar place as before. If we execute Apollo against each schema, we'll generate 3 different sets of Swift files too, which doesn't make consuming these queries any easier for our product engineers. And that's where the last step comes in. Using a little bit more tooling, we created a Swift tool that parses the code generated by Apollo and creates one umbrella module for accessing any query for a given GraphQL server. This allows developers to consume only one interface rather than needing to worry about 3 distinct ones. Let's quickly illustrate this with an example. Let's take this query. Beginning with a simple query, let's say that users can only enable auto merge on github.com and only upload videos on github.com and GHES 3.1. Our query rewriter will use the introspection of each schema along with a bit of AST parsing to write out 3 separate GraphQL documents. The result is 3 separate queries, each of which are guaranteed to succeed for each of these different GitHub API versions. From here, we can execute Apollo's Swift code gen, which will turn our GraphQL documents into 3 separate Swift types and files that our app can then execute. We see there's a bit of duplication here, so let's see how we can fix that. To make this easier for our product engineers, our type gen then creates a generic anonymous interface for all 3 of these types, exposing optional values for those which might not be available in all GraphQL schemas that our app supports. This approach means that our team can create queries that work for any GitHub GraphQL API without needing to write explicit introspection checks at runtime. The end result is a much better product for our customers. This approach is still something that we're iterating on today, but we've found the results to be quite promising. Just another example of how GraphQL introspection can be used to build better products. So let's recap. We took a look at what GraphQL introspection is, which is looking within. We took a look at introspection at runtime, how we can execute queries to decide which features to enable or disable to prevent errors from our queries at runtime. And lastly, we took a look at introspection as an input to other tooling, how we might use GraphQL ASTs and GraphQL types to build type safety for all of our products. I want you to kind of consider these part of your tool belt. Don't reach for GraphQL introspection to solve every problem, but realize how you can use GraphQL introspection to build better tools and to build better products. If you want to learn anything more about what we talked about today, go check out these different links here in our slides. There's some really great tools that are out there to use GraphQL introspection and do some really awesome things. And I want to say thank you so much for having me today. It's been a pleasure talking. Thank you.